so on. For example, let me just go ahead here and then create one more function, void, and let us say write greet function. Okay, void greet. So I'll go here and then I write serial dot print ln. I just write welcome everyone. Welcome everyone. This is a greet function being printed. Function being printed, and close the semicolon and then close this. So this is one more function right now, right? There's one more function right now here. Now let us go ahead and call this function also here. After every this thing, I'll just invoke the function. Now what I'm doing is very importantly, I'm just taking you a little bit more into the functions now, because it's easy to implement and also really is very handy. So like this is a function I've created. You know this thing very well because void is the one which we use to define the function, followed by the function name what I've given, and then inside this curly braces whatever I want to do it. So I just printed one statement inside that. Now what I want is I want by default only these two statements will be, these two functions will be invoked by the Arduino. That is the setup function and the loop function. They will be by default invoked by the Arduino, but these functions will not be invoked. When I say invoked, what does it mean? It means that they will not be called upon. Okay, so this two will be called and they'll run, but this will not be called. So I need to call this function. So what I'll do is I'll go here and call the function by just writing greet. That's all. Okay, now what will happen? This function will start first as default because setup has to run every time the first one. Then we'll have a set white loop here. So this loop will go ahead and work perfectly fine. So this will keep on doing it. And there's one more function which we have it, which is not going to be called upon by itself until you make a call to it, right? So what I'm doing, I'm just making a call to this function inside this loop. So what will happen now? This will get executed first, and then the second line, then the third line, and then this line, and then the delay of 500 milliseconds. Let us say I could go ahead and write delay between them also of 500 milliseconds so that I can see some slight changes and timing differences. Now, good enough, right? So you see this, I have added a, let me just go ahead and expand this window. I have added the semicolon. Don't forget that. It's very necessary out there. And then let us run this, start the simulation. And you see this, it runs amazingly awesome, right? Who is sending you all these messages? The Arduino is sending you messages. Hello, welcome. This is a greeting being printed. So what is happening? Like you're able to get, like I told you about the serial, use the serial print ln, serial print always possible. Now you're able to make out here. This might be running it. If you have an output coming in, might be LEDs glowing in and something, you might be able to see that, okay, something is working. But in case, for example, now we have not connected anything, but we are using this microcontroller to do something. How do you able to make out like what is happening, whether it is going to some function or not? But if you write the serial dot print, that is, if you write some print statements, you will be able to get that log. So you can go ahead and see this. Now able to see like, yes, it is printing out there. So this is very important. I would really suggest you to do this.